welcome to the YouTube channel Exam Ignite. Today we are continuing with the module 5 part 2, that is uniform plane wave topic. Here I will be discussing the derivations and the Poynting theorem derivation and the skin effect, which are most important for the exam. Starting with the uniform plane wave. Before going to that, we'll go with the transverse nature of EM wave. That is, consider a uniform plane wave propagation along the x direction in the medium where there is no free charges. From the Maxwell's equation, we know that nebula dot d vector is equal to rho v. Let rho v is 0. Then what? Nebula dot d vector is 0. We know d vector is epsilon into e vector, that will be 0. So the electric field, nebula dot electric field is 0. From the Cartesian form, we know that nebula dou ex divided by dou x plus dou ey divided by dou y plus dou ez divided by dou z is equal to 0. For the uniform plane wave in the x direction, the y component and the z components are constant. So that is 0. So only we get to the dou ex divided by dou x is 0. Consider the wave equation here. That is nebula square E vector is equal to mu epsilon naught delta square E vector divided by dou t square. That is my third equation, which is in the 3D. Since it is an independent of y and z, we can only write it for the x directly. That dou square E vector divided by dou x square minus mu epsilon naught into dou square E vector divided by dou t square is equal to 0. If for the three components also similar way, for the x, y and z we can write. Now continuing with this equation, here mu epsilon naught of dou square ex divided by dou t square is 0. Since mu and epsilon naught are not equal to 0 here, we can write it as dou square of ex divided by dou t square is 0. So where that is a 0 or constant. Uniform plane wave electromagnetic wave can have either electric field and magnetic field components along only the normal to the direction of propagation. So or else we can say it is the transverse nature of the electromagnetic waves. Next topic is uniform plane wave. A field has some magnitude and direction in a plane containing it. For uniform plane wave propagation in the z direction, E vector and that is electric field and the magnetic field are not function of the x and y. They are the function of z alone. So this is a plane. This is our h vector, E vector. So Maxwell's equation in the free form, we can write it as 1 and 2. We know that nebula into E vector is equal to minus mu naught dou h vector divided by dou t. Equation 1. Nebula into h vector is equal to mu naught dou E vector divided by dou t is equation 2. So what is the dot product of is 0, and here also the dot product of the magnetic field is and the current electric field is 0. Curl of the equation, there's the first equation, take the curl of that equation, that is cross product the nebula cross E vector is equal to minus mu naught nebula cross delta h vector divided by dou t, that is a vector component. By the vector identity, we know that this term is 0. So from the equation 4, we can write this term as 0. Now put that in the equation 5. On substituting that, this becomes square E vector is equal to minus mu naught and this nebula into delta h vector by dt. Here minus gets cancelled. Changing the order of the differential with respect to the space and time, the equation 5 as dou x nebula square E vector is equal to mu naught dou by dou t of dou into h vector is a 6 equation. So from the second equation, we can write nebula square E vector is equal to epsilon naught mu naught dou square E vector divided by dou t, which is my 7. Wave equation in the time domain for the electric field of the 3D. Now this is of the wave equation in time domain for the magnetic field in the 3D. Now the scalar forms are given like this, where further you have to assume that these are electric field of x component and y component. Only the electric field is s component and magnetic field is y component. You can write this two uniform plane wave equations in 1D. One dimension. Now classic wave equation is what we know, delta nebula square f minus 1 by v square dou square f vector divided by dou t square is 0. Comparing the 7th one and 8th equation, that is above here 7th and the 8th equations with this main equation, we get to know that v is equal to 1 by square root of mu naught into epsilon naught, which is the velocity of the speed, that is 3 into 10 power 8 meter per second. Next comes the Poynting theorem, most important and most expected question. Poynting theorem. First, write the statement. It states that the energy dissipated in a given volume that is free of any sources is equal to the sum of the rate at which which is decrease in the electric or the magnetic energies it stored in the volume takes place, and the rate at which the energy inflow occurs through its surface, that is E vector cross H vector. Proof. You have to start with the Maxwell's equations. Two Maxwell's equations. Consider it as equation 1 for the electric field and for the magnetic field as equation 2. Now you have to cross product those two. Considering that, you have to write it as nebula of E vector cross H vector is equal to H vector of nebula cross E vector minus E vector of nebula cross H vector. This is my equation 3. Now put 1 and 2. Substitute those two in the 3. So on substituting that, you get this equation. Just write this equation in this place and this equation in this place. And then simplify. Here simplifying, remove minus mu outside the bracket and multiply the H vector inside. Here remove the J vector epsilon naught and place the E vector inside. Here E vector also gets multiplied with the J vector. We know that H vector, this is a standard formula you need to know to write this, that H vector of dou H vector by dt is 1 by dou H square divided by dou t, this part. And for this part, you have to learn these two equations to write this. So and then substitute that, you will get this equation. Take the volume integral on both the sides. So taking the volume integral on both the sides, what do we get? We get this equation. By Stokes' theorem, we know that what volume integral of nabla of E vector dot cross H vector is dou V is equal to surface integral of E vector cross H vector into ds. So we come to know the Poynting theorem final equation by the Stokes theorem. Next is the last and the most important topic, that is the skin depth and the skin effect. When an electromagnetic wave enters a conducting medium, its amplitude decreases exponentially and becomes practically zero after penetrating a small distance. As a result, the current induced by the wave exists only near the surface of the conductor. This effect is called as what? Skin effect. If x is the distance traveled in the medium, and E is the amplitude, then the dependence is E is equal to epsilon naught E minus alpha x, where our E naught is the amplitude either at the time of incidence or at the same point in the medium where x is taken as 0, and alpha is the attenuation constant. At the penetrating depth of x is equal to dou, let the value of x be x is equal to 1 by alpha, that is x is equal to delta, that is 1 by alpha, at which time E is equal to minus alpha x, that is 1 by E, which is value is 0.368. So we can write it as capital E is equal to 1 divided by small e exponential into E naught. So where the delta will be the depth of the penetration or the skin depth. So defining that the skin depth or the depth of the penetration is defined as the depth of a conductor at which the amplitude of an incident wave drops to 1 by E times its value of an amplitude at the time of incidence. So but you can say delta is equal to 1 by alpha. For a good conductor, alpha is equal to square root of omega mu sigma divided by 2. Now for the delta, it is 1 by alpha, so reciprocal 2 divided by omega mu sigma, which is equal to square root of, on writing as omega has 2 pi f, you can 2 gets cancelled, so square root of 1 divided by pi f mu sigma, which is the value. On substituting the value of pi, mu and sigma, we get to know that 0.066 divided by square root of f is the value of the depth of the penetration, that is delta. And you have to write the graph for the skin depth and skin effect. You have to write the graph while you are explaining this. So this completes the overall series of the electromagnetic theory. All the 5 modules are uploaded in the channel. I have provided all the 5 modules links and the playlist links. Go through all the videos. Do learn all the derivations. It's very easy to understand and it's written in an easy manner. Share with your friends and do subscribe the channel. Thank you.